10 years ago, I had a personal project. I wanted my washer and dryer to send me a text message when they were done with their cycles. And I did this through monitoring vibration in the machines. Then when certain conditions were met, a text message would be sent. And I took weeks to write this and lots of code. And then I find out that with NanoEdge AI Studios, I could have done this in a couple of minutes. François, you built a demo that does exactly that. Monitors vibration in a system and triggers events based on anomalies in that vibration. But we'll get to that demo a little bit later. Right now, tell us, what is NanoEdge AI Studios and who is it for?
Thank you for the question. NanoEdge AI Studio has been developed with the embedded developer in mind and technical designer in mind. The idea is to have a low-code, almost no-code tool, so everyone can develop a machine learning algorithm for their microcontrollers. And so that was really the starting point for that project that been developed since now it's been like 4 years in development. So yes, that's the starting point, developer.
ST has fully embraced artificial intelligence, and you've been doing so for quite some time, 4 years, in fact. Was this part of a plan?
AI, it's important to de-dramatize AI. AI is a common buzzword, big word. And now the idea is, at the end of the day, machine learning, I prefer machine learning to AI. It's more realistic, I think, is just another way to program machine. So usually you program with if this, then that, and here we are more using example from data. And when we think about data, you think about sensors, and when you think about sensors, you think about microcontrollers. So at the beginning, we started to try to understand where is this market of AI in terms of volumes. And we know for sure that there are a couple of billions of humans that are producing data that are managed by the big guys in the tech industry. But in the meantime, there are, let's say, hundreds of thousands of millions of machines that are producing data also. So we try to find what is the equivalent of the smartphone for machines, to do a metaphor. And the smartphone of machine is the microcontroller. It's the equivalent for machines. That's where what we thought at that point, and that's why we went in that direction, to embed AI and machine learning inside microcontrollers.
AI became mainstream about 2 years ago. Before that, no one was thinking that AI could really do much, let alone do their job for them. So how did ST know to get into artificial intelligence? Did the industry demand it?
There were already a demand. The one big challenge is to make happen the needs and the way of describing the needs between an industry with some typical use case from predictive maintenance, for example, the same example as you took, and the possibilities that are offered by the technology. So that's really the idea of that kind of technology, is to present use cases, to explain to those embedded developers that are not used to use AI and to think this way, that they have possibilities that are offered today. And so it's a big part of our job in terms of presentation, make it simple, make it easy to use for any kind of embedded developer, even if they completely forget their algebra courses, it's fine. And the tool was designed in that philosophy in mind.
Was NanoEdge AI Studios adopted right out of the box? Are companies already developing solutions with it?
We have well-known companies that are using the tool. Their teams of embedded developers are using the tool to embed those AI libraries inside their product. Some are already showcased on our website. So I really encourage a product designer to go and check what kind of real product can be developed using that technology. And in the meantime, in the same time, we have a big community of enthusiasts, makers, those people who are really creative in the way of using every new tools available. And we really try to help them also deploy those new product with this AI approach, machine learning approach, kind of way of thinking things in terms of functionality inside their project and their product. So yes, the community is growing, and it's very very cool to see that occur live, to been there since the beginning of that journey, and to continue to help users, yes, to imagine the future product with those capabilities directly inside. In reality, we started really early that story. We've been in the past, my team, a startup that has been acquired by ST 2 years ago. And the first product with one of our libraries inside, so the result of the tool is a Bob Assistant. And Bob Assistant is a pretty interesting product. It's a product for predictive maintenance. So it's typically the use case that is nearby the story you had in the past. It's a small device running on a microcontroller, of course, using vibration. You stick it on the machine, a running machine, HVAC, pumps, those kind of industrial machineries. And in matter of minutes, he will understand and learn the behavior of that machine. And then it will switch to detection automatically and check every 5 minutes on the battery if the model that has been created locally is still corresponding to the reality of the behavior of the machine. If not, it will trigger an alarm saying, oh, you should go and check that machine. And what is interesting for a product designer, it's also in terms of business. Why? Because using the same hardware, as a microcontroller, a low power microcontroller, a battery, an accelerometer, a standard accelerometer, nothing fancy, and a small LoRaWAN radio signal system, they completely changed the price of the product, because they were starting from a shock detector device, but using an AI library, they were able to transform this simple product, a shock detector, to a predictive maintenance product. It's completely different in terms of value they are bringing to the final customer. So also in terms of product design, I really like the idea of AI is also an opportunity to rethink sometimes your product, to think what kind of value I can add for free. It's just a pure software algorithm you add in the product, so you use the same microcontroller, but you bring more value to your product, so to your customer.
Development with NanoEdge AI Studios is fast. Could an engineer develop code out in the field and deploy it immediately?
It's a key aspect of the product, of the software, the studio, really, to develop. The metric we had in mind when we started this development of the tool is that the overlap between data scientists and embedded developer is almost non-existent in terms of knowledge. So at that point, we thought, okay, so if we are targeting embedded data scientists, it will never go to microcontroller. So we should target embedded developers who want to be very pragmatic. I have a problematic, I need an answer, and I need it fast. And please talk to me in C code if you want, but not in Python, PyTorch, or whatever. That's when we decided to create an AutoML tool, meaning that you are describing your problematic as a developer using data from your sensor. And then you ask the tool to find the right algorithm, the right machine learning algorithm, the combination. I explain it a little bit more in the demo and the tutorial. And the tool is doing the hard work, the heavy, the mathematics for you. And then the rest of the story is really business as usual for an embedded developer. You have a library with a simple function, learn, detect, classify. Everyone can use that. So that was really the main goal of this development.
With all the makers and hobbyists and engineers out there already using this software, have you seen any other uses that really caught your eye?
As I said previously, it's another way of developing. Okay, so when you start with that in mind, as you may imagine, the possibilities are infinite. And I've been in a lot of client meetings, okay, presenting the technology, explaining what are the possibilities, the way it's easy to use, etc. And every time I get a different use case, like every time. You can use it in white goods, appliances. You can use it in drones, in IoT, of course. And when we check the list of clients, the companies are like spread in terms of businesses. It's could be completely different industries that are working on the same idea of classifying phenomena, from their machines or from their devices, or maybe do regression, meaning extrapolation of value. Say, I want to be able to. I had the example this week of a manufacturer who want to check the belt tension on their machine, and they want to do so using vibration. If you do it the traditional way, it's impossible to do that kind of magic operation, because you are going to struggle. What are the threshold? What are the limits, and etc. So what they did, they logged some data from their machine at different belt tension. They input those data sets that are simple data sets from the accelerometer. Everyone every embedded developer can do those kind of data collection. And then the tool provide them the regression rule that can make corresponding the vibration and the belt tension. So they can add the functionality inside their machine and trigger an alarm if the belt is loose, to make the technician fine-tune the belt tension automatically.
Okay, now for some technical questions. If I wanted to set a trigger event, how would I do that? Would I just monitor for anomalies in a loop and then set a trigger that way?
NanoEdge AI libraries is going to provide you a similarity level, saying, okay, it's like 0% similar. We are completely outside the usual behavior of that machine, or we are at 50, or we are completely aligned with the model. And then the rest of the story depends on your project, but it's a simple value to use. You have a scale between 0 and 100% similar. So you can say, okay, if it's below 80%, I should first trigger an LED blinking on the device, meaning there is some anomalies, but it's okay. It's manageable for the machine perspective or the device perspective. That depends on the use case. But if we go below 50%, I should send a Bluetooth, LoRa, or Wi-Fi, trigger to the system, to the dashboard. We are really focused on the machine learning, aspect of the things, and the output of that is a simple value. So anyone can use that in their project, because it's like creating a smart sensor. I have this image in mind that there are tons of species, okay, with eyes, but only one can read a book. It's not a matter of sensor. It's a matter of managing the data and understanding the data. So we are creating those small algorithm brains that will manage the data and transform into an information. You know, we go from the signal, raw signal, to an information. And then this information is like I said, business as usual for an embedded developer. You can, or a product designer, they can say, okay, we had an example of a cooking appliance manufacturer. They wanted to be able to estimate the grinding level of the food that is nuts that is inside the blender, you know, based on vibration. So in that example, we created some kind of grinding level sensor that is not existing on the market. You can not buy that. Mm-hmm. but using algorithm and machine learning algorithm, you can create that virtual sensor that is a grinding level sensor.
Time. How long something happens or how long something doesn't happen. Can NanoEdge AI Studios keep a log of that, or is that part of the developer's responsibility?
This part is their usual, you know, work and project. There is most of the time they think about how to use that new information. In my example of the Bob Assistant, the small device to check machines, there is also in the main program a strategy to say, okay, maybe if the first time I see an anomaly, because I don't want to bother the maintenance guys for a small event that is not lasting in time, you know, there is no, someone hit the machine and it just generated an anomaly, but it didn't last. So you don't want to wake up a German technician, you know, at 2 in the morning for a glitch in the matrix. And so inside the product, the main program, there is a confirmation strategy. So you say, okay, there is an anomaly. I will log that and try again in 5 minutes, for example, or 1 minute. If there is an anomaly, I will short the period between two checks. And then if I have a triple confirmation of things are going wrong, then I will trigger an alarm. So this way you don't have false positive, you know, you don't have false alarm or those things that are counterproductive but this part is more about product design. But you can have this thinking when you are sure to have the information. Until that point, it's basically useless to try to imagine what is my main strategy. You need the information and then you can build on that. So the tool is providing the users the information, and from there they can continue their journey of product designing and so on.
Within NanoEdge AI Studios, there's a handful of different libraries to choose from. One says hobbyist, embedded developer, or data scientist. How do those libraries differ?
Is completely the same. It's more for us to understand who is using the tool. It's like for statistics matter only, and because we always want to know better our community, and if we can help and design the help we can provide based on who is using the tool. So it's important for us to still be here to listen what are the requirements, because sometimes they are typical for professional, you know, users, and more for hobbies they are slightly different. So we try, it's just a matter of metrics and understanding who is using the tool.
It says ST is there for support using NanoEdge AI Studios. Is that available to everyone?
We have different channel of support depending on who is at the end of the keyboard. We have forums, public forums from ST community that are available for everyone, and we are here to reply, and we have people that are doing that all day long, so you can have support there. And also, if you are an ST client as a company, you have support from all different regions around the world to help and guide you on those projects. Yes.
NanoEdge AI Studio supports a lot of ST's development boards, but it could hypothetically support boards like Raspberry Pi or BeagleBone. What are the requirements for that?
We are targeting Cortex-M kind of microcontrollers. So why? Because we are a lot more focused on low power, efficiency, those kind of things. That's why I'm talking a lot about smart IoT, smart sensors, those things that are running on battery or small solar panel, and those kind of projects. But the bigger the CPU, the better. Of course, if it can run on a very small STM32C0, the last one from ST, that is really, really small and really cost effective. I'll let you imagine that most of the outputs are very small in terms of memory footprint. Most of the time you are ending the result of the studio search engine will provide you a library with, let's say, 10 kilobytes of RAM in terms of consumption and 20 of flash. So there are a large amount of microcontrollers that can handle that size of libraries, and yes, of course, the bigger, if it's bigger, you can also make it run. Yes.
In my washer dryer project, I use a lot of memory, a lot of RAM. I'm brute forcing my solution. But within NanoEdge AI Studios, you can control how much RAM and how much memory you're using. Can you tell us about that ability to tweak?
Okay, it's a very interesting and important point. We know we are embedded developers in the team. We have a lot of them, and so we know the concern about memory footprint. It's an important topic, and we respect that, and that's why directly inside the tool. And I really encourage every developer to test it, because you can test it for free. You can set the memory envelope you are ready to give to the functionality. So you say, okay, I have, for example, 20 kilobytes of flash available and 10 of RAM. Please, Studio, what can you do with that? So that's really the philosophy of the tool. And then the internal search engine is going to combine fundamental algorithm bricks that are around signal processing, or machine learning, feature extraction, with that memory footprint envelope in mind, saying, okay, it's a hard limit. I cannot go with more than this. Because the user asked me to find what is the best solution I can provide with this envelope, within this envelope. And so that I really love this part of the tool. I think there is some kind of magic in that. You see the tool is searching and trying to improve inside the envelope. So I find it really the coolest part of the tool is this search engine, because in matter of minutes, it will do a work that is representing months in terms of algorithms, combinations, mathematics, live from my PC. So yes, I really like this part. The benchmark engine is terrific.
I have a personal question. Do you think engineers have to be adept at using AI in the workplace? And if they're not, they might be left behind? I'm curious what you think.
As I said previously, and I think the question is completely aligned with that, is that AI is another way of programming, okay? Not a new language, it's a new way of programming. It's bigger than the language. It could be in different language. At the end, it's a new strategy of programming things. So as an embedded developer, of course, I should have a minimum level of understanding. But if you want to go the hard way, you will need to be a data scientist at some point, because you will need to manage, and that's where AutoML enters the game. Because the idea of AutoML, and the studio is really to bring you the value, the knowledge of using AI in a pragmatic way without going back to school with your book, algebra book, you know, and those kind of things. So we are speeding up the AI adoption in the embedded developer typical landscape, because we are doing, and our mathematicians are doing this for them. And that's the idea of the tool, is to provide the value without the effort.
François, thank you for talking with us today.